All right, so we make alkenes through elimination, and then we can add stuff to alkenes through addition. So let's take a look at what's going on here. And remember when we were doing the E1, SN1, right, substitution versus elimination, it's kind of the same idea here. And we said previously that heat favors elimination. And we didn't go into why, but now we're going to go into the why here. So on one side, we've got our alkene. Across this alkene, we're going to add a molecule of AB. Right, we've gone ahead and added AB. So let's go ahead talk about going from our alkene to our alkane. And let's think about the thermodynamic considerations here. So let's think about delta H here. Think about what we're doing here. We're going to break one pi bond, which is our alkene, and then one sigma bond, which is our AB bond. And then we're going to form two sigma bonds, right? Our carbon A and our carbon B bond. And if you think about it, remember that sigma bonds are stronger than pi bonds, and that forming a bond is what releases energy. So here we're forming more stable bonds, and so this leads to an exothermic situation. And so remember, when does this matter? Well, it matters for the spontaneity of a reaction, and that is determined by delta G, where if it's spontaneous, delta G is negative. So we have our equation, delta G is equal to delta H minus T delta S, and we're saying that in this direction, we have a negative delta H. Let's take a look at our delta S, right, going from left to right. Here on the left side, we've got two molecules, right? We've got our alkene and then our AB. And then on the right side, we only have one molecule, right? Our addition product. And so going from left to right, we've lost our delta S. We've lost entropy. And so this part is negative right here. But if you think about this whole thing is negative T delta S. And so a negative times a negative ends up being a positive. And so you can see we have one part that favors spontaneity and one part that disfavors spontaneity. And so it all depends on this value of T. And so if we think about it, when we have low temperature, delta H dominates. And we're seeing that when delta H dominates, right, we're going to be going towards the right side of our equation here. And so addition reactions work better at low temperature. And then we can have the exact opposite if we go from the right side to the left side, right? Both of our signs of delta H and delta T are going to flip. All right, this part will be positive, this part will be negative. And so when we're talking about when we have a high delta T or high temperature, right, our delta S is going to dominate. And if we take a look at which side is entropically favored, it's going to be the elimination side. So we can see how by controlling the conditions, we can control which way our reaction goes, towards addition or elimination. That's something that we learned about before, but now we're learning more about the background of it.